Welcome students. Today I'm going to discuss one topic where students generally get confused. This is two programs on numbers. As you can see on the board, prime factors versus prime factorization. So we'll discuss these two topics. One is prime factors of a number and prime factorization of a number. As the common term prime is there, that makes most of the student confused. Let us see first what is prime factors. Here I have taken an example, n equals to 10. So if n is 10, so factors are the numbers by which the number 10 is divisible. So we are getting factors as 1, 2, 5 and 10. Out of which those which are prime numbers, they are prime factors of 10. That means 2 and 5. On the other hand, prime factorization is a prime numbers whose multiplication makes the number itself. So here I am getting 2 into 5, 10. So both I am getting here same. But let us take another example, 8. So when I am taking number 8, factors we are getting as 2, 4, 8 and prime factor is 2. But in case of prime factorization of 8, I am getting 2 into 2 into 2 makes 8. So the prime factor of 8 and prime factorization of 8 is not same. Hope you have understood this concept. So we'll do programs on finding prime numbers of a number n and prime factorization of n. Here is the program on prime factors. So let us go through the program step by step. So initially what I'm doing, I'm taking the number from the user through scanner and storing it in n. Now you'll see here we are running a for loop from 2 to less than equal to n, because we all know 1 is factor of every number and 1 is not a prime number. So I'm starting from 2 till the number. Inside the for loop, what I am doing, if n modulus I equals to 0, that means I is a factor of n. The moment I get I as a factor, now I have to check this I is a prime or not. So I have taken a variable j. I am starting the j with 2. Again, because 1 is factor of every number and the number itself is a factor of it. So for taking a prime number, I am taking the logic to find any factor except 1 and that number. So here is the case, I have to check I as a prime number. So the loop is running from j equals to 2 till j less than I. That means the loop is running from 2 to I minus 1. Now see the I, if block. In the if, I mod j equal to 0. What does it means? If I mod j equals to 0, that means j becomes a factor except 1 and I. It means I is no longer a prime number. So what I am doing? I am making a break from the while loop. Otherwise j will be incremented. Now if this while loop continues till j's value becomes I, it suggests what? It suggests I becomes a prime number. So when j equals to I am printing the I. What is I here? I have already found as a factor of n. And in the nested loop what I found? I found I is a prime number. So what it makes? It makes I'm printing the prime factor I for the number n. You have observed how this loop structure is there. Now we'll proceed to the next program, that is printing the prime factorization. Now let us see the program on prime factorization. I'm going line by line here again. So the class name is prime factorization and I'm taking the number n from the input, from the user, n as input. Now here I equals to 2. Why I'm starting I equals to 2? Because 2 is the first prime number. Now see the loop over here. I'm running a loop till the original number not equals to 1. Then inside that I'm storing the remainder of the division. N modulus I is stored in A. If a equals to 0, that means n is divisible by I. I'm printing I as the factor. So 2 is the prime number already, so 2 can be printed. Now here what I'm doing, I'm reducing the number by the factor. So n equals to n divided by I. So loop will again go to top, again divided by the same number, and this will go on. If a, that means the remainder, is no longer 0, it will come to the else block. What it will do now? Here the I will be incremented. So till the number is divisible by 2, it will go on dividing by 2 and 2 and 2. The moment it is no longer divided by 2, then the number become 3, then by 3, then by 4, till the original number comes to 1. And then the program ends. Now let us see the working of this program. I'm just shifting the mobile to the working part. See over here what I'm doing. I've taken the number as 28. So I've started I equals to 2. So 28 is divisible by 2. So what I'm doing? The number 28 is reduced to 14. Now 14 is again divided by 2. So the number again reduced to 7. Now 7 is not divisible by 3, 4, 5 and 6. 7 is divisible by 7. So now the number again reduced to 1. The moment it reduced to 1, the loop ends. So what will be our output? See, I've underlined with the red line. Wherever the I value gives the remainder 0, that is 227 will be your output. And thus the prime factorization of 28 is 2 into 2 into 7, that is 28. Hope you have understood the entire program. Now I think it is clear to everyone what is prime factor and what is prime factorization. If you see in the logic of prime factorization, I've never or nowhere I've used of checking prime numbers. Here it's not required to check for prime numbers, where the students generally make mistake. Hope you will not do the same mistake. Thank you.